Okay, so first of all, everybody look at your pore plating results. That looks okay? Not very good, is that right? So you see the difference between pore plating and spread plating. Now, what's the reason? What's a major reason? When you have this jaw right there, is that right? Let's say this is a jaw or something. All you melted agar is right here, and the liquid is on the top. So when you pour it, it's not going to mix very well. When you dump, there is not enough agar in the liquid which is we put onto the agar. So that's why it's not solidified very well. Most of the time they need a stir here. A stir needed here, put in a hot plate to let it be stirred. Magnetic hot plate to let it stir, they mixed, then we could do it. And usually also we suggest this melted agar a little bit higher. Basically it's 15 grams per 1 liter, but usually we will up to go 25-ish sometimes. Okay, so that's just want to let you know. There is something reason, that's why your pore plating won't be look very good. So we will talk about this next Tuesday when we do the review. So it should be fine. You can just report it why the reason it's not doing very good. Okay. Okay, today's class, the fact sheets is right here. We will talk about is a different media and for different bacteria. Because of the biosafety reasons, there is 2 bacteria which is new. I never heard about that, but we can do the test to see their growth situation on the agar. Okay, so first one is CF, Citrobacter fludi, and the last one is Morganella morgani, which is both gram-negative bacteria. Okay, we'll talk about that. Okay, so the topic today, we talk about Lab 8. The topic today is introduction of bacteria media. Okay, we already talked about in the lecture. We have support media, let's say you nutrient broth. Now, of course, you put an agar there, will become nutrient agar. And we talk about selective media. Because we have a certain ingredients so will favor certain bacterial growth, and the others will inhibit. And then we also talk about the differentiated media. Differentiated media basically is biochemistry reaction. So we will be seeing the color change of colony. Now, today's work, we want to introduce you some of these media, how we're going to do these things. Okay? We still need a nutrient agar.
We have.
Yeah, we still need a nutrient agar to do the demonstration. Okay, the first agar we want to introduce to you. Here's Makanki agar. Makanki agar looks like this. Oh, it's too wet. So once it's too wet, you guys have to use you have to use these paper towel to make sure it's dried out. Well, it's too wet. It looks like this. This is kind of purplish. Now, why it looks like a purple? The reason is the major ingredients is crystal violet. Because of the crystal violet, so only gram-negative bacteria grow, and the gram-positive bacteria will not grow. The reason is crystal violet is attacking cell wall, peptidyl glycan. Okay? The second thing we also want to mention, it is of course a differentiated media because lactose. It could become lactose fermentation positive and lactose fermentation negative. If it's lactose fermentation positive, it is pink colony. Otherwise, it is colorless. Now, why it is a pink colony? The reason is that there is a pH indicator called neutral red. And the neutral red at low pH, let's say pH around 4 to 5, this is turns pink. So, McConkey agar overall, it is a selective media and a differentiated media. Okay, so that's the first one. And we have this question in the exam for the extra points. Some of you get, some of you didn't do very well. Second is mannitol salt agar. What it looks like? Cherry red looks like. Very red. Okay, same thing. Make sure it's dried out, so you use paper towel to clean inside a little bit, because it's all dried out. Very wet, just come out of the refrigerator. Okay, what other ingredients are there? Number one, mannitol. Mannitol is a modified sugar, okay? So mannitol, because of the mannitol, it could happen is mannitol fermentation positive and mannitol fermentation negative. If mannitol fermentation positive, what it looks like? It will be a yellow color, the colony. Okay. This is yellow color. And the mannitol fermentation negative is colorless. The second thing, you have a salt there. Okay, what is the concentration of the salt? The concentration of the salt somehow between around like 3%. Because of the salt, so it had to be differentiated two different categories, halophile and non-halophile. Halophile, which means bacteria like salt, so salt lover, and this is dislike salt. So, very simple. If the bacteria can grow in on the mannitol salt agar, it is a halophile. Let's say Staphylococcus aureus, Staphylococcus epidermis. If the bacteria growing on the mannitol salt agar, which is yellow color, which means it's mannitol fermentation positive. Otherwise, it's mannitol fermentation negative. So the question in your lecture exams regarding the mannitol Salt agar, the answer is it's a selective media because we are talking about halophile compared to non-halophile. And some of you doesn't even read it, just think it's the same. Not the same, you have to read it, okay? So, this is the same thing, it's a selective media. And it's a differentiated media. Okay, that's the second one. Third one we want to talk about is blood agar. Okay, blood agar is very red, like blood, like this. What did the blood agar have? It is a 5% sheep blood, add nutrient agar base, or tropic soil agar base. So you can understanding it is just a normal agar. You add 5% sheep blood. The reason is we mentioned because in 70s, people find sheep blood is very similar to human blood. Okay, so blood agar is number one, enriched media. Which means the bacteria can grow dramatically. Is that right? There is only exception if it's a fastidious bacteria, it's not going to grow. Let's say Haemophilus influenza, Neisseria, or those. So enriched media, except for fastidious bacteria. And very important, it is also a differentiated media. Why it is a differentiated media? Alpha hemolytic. We talk about that. Could be dark green color colony. And that could be so dark green. Okay? A beta hemolytic, which means it is transparent zone. Last one is gamma hemolytic. That means nothing happens here. Okay? So that's a blood agar. Last thing, we want you to have a little bit of fun. So, bring some of the agar in my lab, which looks like a pancake, is very large. Pancake. Because one day I misordered. I didn't read the size of the agar plate, so I ordered this pancake. Okay, now what is this agar? This agar is very similar to this one. Look at the color close. It is a brucella agar with vitamin D and K. So what is a brucella agar from? Brucella agar is a modified blood agar. So there's a heme there. It is usually, obviously, for cultivation brucella. But we can cultivate this one for Campylobacter jejuni under microallophilic environments, plus the vitamin K and D, which give them extra nutrition. So it is an enriched media for fastidious bacteria. So that's why I just gave you an example. For brucella agar with vitamin K and A, this is for fastidious bacteria. Same as function as chocolate agar. And remember, we talk about chocolate agar. What is chocolate agar? It is 5% sheep blood and nutrient agar base. We heated it at 70 degrees Celsius. Then looks like a chocolate color. So we call it a chocolate agar. Okay, today's work is very simple. How simple it is? You can finish maybe 5 minutes or so. Okay. We have 4 different agar. Plus another one is 5. We're going to draw here 4 different agars. What are the 4 different agars? The first agar is neutron agar. I write Na. The second agar is Macanchi agar. Third agar is blood agar. And the last one is mannitol salt agar. Every single agar, you split them onto 4 different sections at the back. Of course, at the top, you need to write your initial and your bench number. Okay? Initial and your bench number. Then, we will do is spot inoculation. Spot inoculation. What do we do spot inoculation? Use loop to pick the bacteria from the slants. Just do a little bit of zigzag. What are we going to add there? A little bit zigzag. Okay? Very tiny zigzag for each. Very tiny. What are we going to add there? We will add E. coli on every single place on the side. We know about it. We will add Staphylococcus aureus. So SA, 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 and SA. Then we will add Citrobacter freundii, CF. So we add CF. CF is in plus. So we add a CF. And CF. The last one we want to add Mongonella morgani. So we add MM there. You have to label the name first, okay? Acronym first. Then you do a spot inoculation, which is pick the bacteria here, 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 and here. The same bacteria, you can use a loop to do multiple times. But the different bacteria, you have to flame it. Otherwise, you cause cross-contamination. So, very important. Flaming loop between bacteria. Now, this large one, what are we going to do? This will be doing. The bench you use there, 4 of you will do 1. Same as this. 4 of you will do 1, 3 of you will do 1, 3 of you do 1. So we separate them. One bench we will do 2. We will do split them onto 4. You also do EC, SA, MM, and CF. You work together to do it. We want to see this agar plate compared to the blood agar. Is there any difference? Okay? And also these 2 bacteria, I never heard about that. I only know they are gram-negative. We'll see what their growth situation on the agar. Maybe we'll see some beautiful results. Last thing, you may confuse about these agar. Looks very similar. Look at the edge. Very red. You hold on like this. Very red. This is purple. Looks like a pink red. And that is pancake. So you know the difference. Now obviously neutron blast, you know, it's a different color. Is that right? This neutron agar is a different color. Now last thing we want to mention is that Staphylococcus aureus is on slants. E. coli is also on slants, but you need to make sure you touch the smear there. Okay? MM is in a broth. Shake it before you do. And we also have CF is in a broth. Shake it before you do. Because this is a cloudy area. This is precipitation at the bottom. Okay, make sure you shake it. Okay, go ahead and do it.